Hello and welcome to another one of the Q-Step tutorial videos. Today we're going to be going over normality, everything from histograms to QQ plots, and introducing the concept of bootstrapping. So let's see what it's all about. So, what is normality? This refers to the data following an approximately normal distribution, and we can see this within histograms, QQ plots, and bootstrapping. Don't worry, these concepts will be further explained as we go along. Focusing first on histograms, we must use the term approximately normal. We can only perform this on scale variables, and we should produce a distribution curve and check all of our MCTs to see if they fit within each other. So here we're going to see two examples. First, here's a normally distributed histogram with the corresponding MCTs. We can see that the mean, median and standard deviation are all similar to one another and therefore fit with each other. Here's another one that's not normally distributed, and here we can see that the mean, median and standard deviation don't fit with each other. For example, the mean is 4.039 and the median is 47.458. Therefore, this histogram is not approximately normal. This indicates that further cleaning is required for this specific variable. Now it's time to move on to QQ plots. Here we can see some examples on the right of normal QQ plots and not normal ones. So let's get stuck in more. QQ plots are used as a parametric assumption to test for normality in bivariate analysis. When examining the plots, we're trying to identify whether the data points follow the line closely. We do not want a clear S-shape in our plot, but there can be slight skews in a normal QQ plot. On the right, we can see that this is a normal QQ plot as the data follows the line very closely. Even though there are slight skews to the left of the plot, we do still have normality. Let's talk bootstrapping. Unfortunately, this concept does not have anything to do with boots, however it's still as useful as a pair of boots within multivariate analysis. Bootstrapping allows for us to perform parametric tests without having to worry about normality. And we do this by examining confidence interval levels to see if they match. For example, the values are either both positive or negative. If they do match, then this means that we can trust our P and B values in regression analyses. So let's take a look at an example. In this example, we're running a regression on successful PhD completion and the IVs, gender and age. So in this table, we can see, if we look to the last part of the table, our confidence interval levels. And now for gender, they match, but not for age. So we can trust our P and B values for gender, however we cannot trust our P and B values for age. Thanks very much for watching this video. We appreciate it, and we also hope that you enjoyed it.
Created using Powtoon.